In this video, we will be looking at an optimization problem where we have to maximize the volume of a box. If you've not already done so, press pause to copy down these guidelines for solving applied max and min problems. When you're ready to continue, press play. The problem that we'll be solving is a rectangular sheet of metal 20 inches by 30 inches will have small squares cut out of each corner and then discarded. The four sides are then folded up and the seams welded so as to form a lidless rectangular pan. What size squares should be cut out of each corner so as to maximize the volume of the pan? And then also we need to find what is the maximum volume. So let's draw a sketch of what we're given. We have a rectangular sheet of metal with dimensions 20 inches by 30 inches. And we're going to cut small squares out of the corners. And then throw those away. And the four sides then are folded up. So we're going to be folding up along this dotted line. And we'll have a pan that looks like this. Our question is, what size squares need to be cut out of each corner? So let's let x be the dimensions on the squares. And so that means then when we fold this up, this side up, our x is the height of the pan. The length of our pan is going to be 30 inches minus x from this side and x from this side. So our length of our pan is 30 minus 2x. And then the width of our pan is going to be the 20 minus x off of this side and x off of this side. So the width of our pan is going to be 20 minus 2x. And then our problem asks us to maximize the volume. So we need to maximize volume. Well, volume of a rectangular solid is found with the formula length times width times height. So with our example, our volume is going to be 30 minus 2x multiplied by 20 minus 2x multiplied by x. Now we're going to need to find the derivative of this volume expression so that we can find the max. I'm going to multiply this out just to make our derivative process easier. So our volume then, I'll take the first two binomials first. We have 30 times 20 is 600. 30 times negative 2x is a negative 60x. And negative 2x times 20 is negative 40. So together that gives us negative 100x. And then negative 2x times negative 2x is plus 4x squared. that's going to be multiplied by x. So our expression that I'll need to find the derivative of is 600x minus 100x squared plus 4x cubed. Alright, the derivative of this expression then is 600 minus 200x plus 12x squared. If we set this equal to 0, I can divide through by 4 and give me a simpler equation. 12x squared divided by 4 is 3x squared. A negative 200x divided by 4 is a negative 50x. And then 600 divided by 4 is 150. Alright, we can use quadratic formula to find our x values. So x then is equal to 50 plus or minus the square root of negative 50 squared minus 4 times 3 times 150 over 2 times 3. When we simplify this, we end up with 25 plus or minus 5 root 7 over 3. Oops. 25 plus 5 root 7 divided by 3 gives us x approximately equal to 12.74, and then 25 minus 5 root 7 divided by 3 is 3.92. Now if we look at our domain, if x is 12, taking 12 away on this end and 12 away on that end, that's a total of 24, which is too much because our side is only 20 inches long. So this value for x will not work. So our first question, what size squares should be cut out of each corner? We need squares are approximately 3.92 inches by 3.92 inches. And then our question, what is the maximum volume? We'll just want to put this number into our volume equation. And it looks like our volume will be approximately 30 minus 2 times 3.92 times 20 minus 2 times 3.92 and then times 3.92. This works out to be about 1056.3 cubic inches.